interrupts. Okay, so interrupts, we have different types of interrupts, and we will see the detail of interrupts now. So mainly we will see the interrupts and then the NVIC interrupt priority. How can we set up the priority for interrupts, or at least what are the standards for interrupts priority? So here you will learn a little more about extended interrupts or external interrupts, and you can configure the pin in interrupt mode. So you have to configure a pin in input mode together with interrupt mode. Please try to explore, of course, more about this, whatever the topic we are going through. Please practically you can explore more into the IDE or whatever the tool you are using, either CubeMX or Cube IDE. Try to do this practically so you will not forget it. Okay, so please make sure about the concept of interrupt, and it's different from polling. I think in the communication networks last semester we have studied about the polling. So polling means what? Polling is the process when the CPU periodically checks each peripheral to see if it needs service. Okay, so we have the pin. Of course we have the microcontroller and we have the pin. And when the CPU is executing the main program, every few seconds once, the CPU come and check the status at the pin. So the pin, if it needs any other service or not. So the polling is not really disturbing the CPU operation. It's not interrupting the CPU operation. Every few seconds once, the CPU is coming and checking if there is any service needed or not. So it's just like your mobile phone. So if you keep your mobile phone in the silent mode, for example, during the lecture, you keep your phone in the silent mode. So, but still maybe you are expecting some important message or call from your friend. So even though you are listening the lecture, you are checking your phone every few minutes once if you get any call or not, or if you get any message or not. So that is polling. So the CPU, the phone is not disturbing you. You are the CPU, but you are checking your phone time to time. But in the interrupt mode, it's not like that. It's just like your phone is in the ringing mode. It means even though you are busy, you are now listening the lecture, but your phone is ringing and disturbing you. So it means, okay, you get the interrupt. You are interrupted by your phone, so you need to attend the call. And after you attend the call and you come back to the lecture again. But of course the lecture is going on, but in the CPU means the CPU will stop the operation whenever the interrupt comes, and then it will take the interrupt and it will process the interrupt. After process the interrupt, then it will start to execute the main program again. So that is the difference between polling and interrupt. You can also set the pin in the polling mode or interrupt mode. So I will tell you the disadvantage of using this polling mode. Okay, first, for example, you set up the polling mode now. So the red LED is toggling every 3 seconds. So CPU will look for if any interrupt. We provide interrupt by pressing a button, external interrupt for every 3 seconds. So you can assume here, we set up some kind of LED. The LED is blinking every 3 seconds, and you need to press the button. So the CPU will come and check. For example, whenever if you press the button, the LED will start to blink. Whenever you press the switch or the button, you are setting up some kind of interrupt. So then the CPU, every 3 seconds once, the CPU will come and check if you press the button or not. So in case if the CPU realized, yes, the button got pressed, then the CPU will turn on this LED. Okay, the CPU come and check, and you did not really press the button. Then it will go back to the main program again. And if you press the button, but the LED will not turn on immediately until the CPU come and check. For example, if I set up the time delay as 10 seconds, let's say, I set up the time delay as a 10 seconds, the polling time. So I press the button at 2 seconds. So whenever I press the button, the LED should be on, right? But the LED will not be on. So after I press this at this one, so the CPU is coming and checking if there is any interrupt or not for every 10 seconds. So I need to wait 8 seconds plus 8 seconds after I press the button. So at 2 seconds, I press the button. So the LED will not be on immediately. I need to wait 8 seconds. After 8 seconds, the CPU come on checking. Okay, so there is an interrupt. Someone pressed the button. It doesn't care who pressed, but it get the interrupt. So then it will process that interrupt and then it will turn on the LED. Okay, this is the LED will be turned on after 10 seconds. Then again, after turn on the LED, the CPU will go back to its own function. And the CPU don't care if you press the button between any time. Then again, after 10 seconds, again it will come and check. If no press the button, then the LED will in the off condition. And if it realized again it got some interrupt signal, that is we are giving the interrupt signal by pressing the button, then it will turn on this LED. So this is how it works. So CPU is coming and checking every time, every few seconds once, and then it's taking the interrupt and process the interrupt. This is just for an example LED. So this is how it's processing the interrupt. This is called polling. Here CPU must check for interrupt every 3 seconds. In this example, 3 seconds. Then why do we need interrupt? So we already have the CPU, it processes the interrupt signals every few seconds once. Then this polling is already working. It's handling the interrupt. Then why do we need the another mode called interrupt mode? Okay, in case if you make the CPU to do some computation for a long time, CPU is quite busy and it's doing some important task, then the CPU will not look for every 3 seconds. So CPU cannot stop this important operation computation, and it will come and check every few seconds once if there is any interrupt or not. That is not okay for the CPU. You are affecting the performance of the CPU. Okay, so in that kind of situations, polling will not work. So we cannot use polling. So at that time, what we have to do, so we must need interrupt concept. So it means CPU will not look, but interrupt will come and request the CPU. So for example, whenever I press the button here, this is the switch. Whenever I press the button, then immediately this interrupt will go to the CPU. Then the CPU will process this interrupt. It will turn on the LED and then it will go back to its operation. So here CPU is not coming and looking for the interrupt signal. Interrupt signal is going and telling the CPU, I need this, I need that. So something like that. So then CPU is processing this interrupt. So that is how the interrupt is working. So this is same like your mobile phone. You can just make an analogy always. So this analogy will help you to understand this polling mode and interrupt mode. So this phone ringing is disturbing you. So similarly, whenever the interrupt signal comes, it will go and request the CPU or disturb the CPU, and the CPU will process the interrupt. So what are the different types of interrupts? One is external interrupt, another one is internal interrupt. So external interrupts, these are generated from external peripherals. For example, as I said, this is the push button or rotary encoder, or it can be a relay or anything else. So these all are external interrupts. That is not inbuilt inside the microcontroller, it's outside the microcontroller. That is why it's called external. Internal interrupt means because microcontroller itself have so many peripherals like ADC, timer, UART. So these peripherals can also give some kind of interrupt. Then the CPU will process these interrupts. So interrupts can be coming from outside or it can be coming from inside of the microcontroller. So see the block diagram here. So here you can see, so input line is connected to edge detection circuit, rising edge or falling edge or both. Okay, so this is the input line. So this is connected to this edge detected circuit, and this edge detected circuit is connected to this rising edge or falling edge triggering trigger selection register. Okay, so that the edge will be used to generate the interrupt. Okay, so this can help us to generate the interrupt. Sometimes events can also be used to generate pulses. Event. So remember, interrupt and event, these two are two different things. So for example, if you are not using your laptop for a long time, the screen goes off automatically, right? It's changing the mode, it goes to the sleep mode. So how it's up, this is called event. So this event, and after when you come back to your table again, maybe you move the mouse or you move the cursor, then the screen comes back. This is called event. So when you move the cursor, then immediately the CPU gets interrupt and then it gets awake and it becomes active again. Okay, so when interrupt occurs, it goes to pending request register. Where is the pending? This is the pending request register whenever the interrupt occurs. So here we are having input line. So the interrupt is coming and then it's going through this OR gate, and then the interrupt is going through this AND gate and then going to this pending request register. Because sometimes why we have this pending request register, because we need to temporarily store this interrupt signal until the CPU come and pick up this interrupt. Okay, so then NVIC interrupt controller will select which interrupt should be processed first if there are more than one interrupt. So we are talking about one interrupt. Maybe we have more than one interrupts at a time. So maybe you have interrupt 1, interrupt 2, interrupt 3. One is coming from the timer, one is coming from the ADC, maybe one is coming from the switch. So there are so many interrupt signals coming one after another or maybe at the same time. So how the CPU can handle that? So if you have so many tasks at the same time, you need to prioritize, right? You need to priority the task. How do you priority the task? It's based on the importance. Maybe you have an assignment from microcontroller course, you have the another assignment from another course, and maybe you have some personal work to do. So all the task is coming to you at the same time. But you are the only one person have to do everything. But then you have to set up the priority. Which one is you have to do first? Maybe you have to do the assignment first, and then you have to do the personal things next, or maybe you have to do in the other way. So you set up the priority, how important is the task and things like that. But in microcontroller, we cannot set up the priority on the spot. We need to set up some kind of standard priorities. So we have some kind of priority levels. That is what this NVIC is doing. So NVIC is setting up the priority to the interrupt in this register to the interrupt signals. So maybe the interrupt 1 have the highest priority, and interrupt, this is the highest priority, can be let's say 0, and then the interrupt 2 also have interrupt 2 have priority number 1, and then the interrupt 3 have priority number 2, and so on. So we set up the priority level to each interrupt. Then the CPU will take the highest priority one first, and then it will complete the process of this one. After finish this, then it will come to this interrupt 2, and it will take this interrupt 2, and then it will process that, and so on. So this NVIC is helping us to set up this priority. So we will see the detail of NVIC now. NVIC, nested vector interrupt controller. We will see that now. Okay, mask registers are used to enable or disable interrupt requests. So here mask, this is the mask register. This mask register, sometimes we need to mask some interrupts. This is not really important. If some interrupts are not really important, we can hide them. We set up the don't care condition. And sometimes we also have the software interrupt register. It helps to handle interrupts from software. Okay. So yes, sometimes you are processing something in your PC, but you don't want that. You want to escape from that. You are pressing some button. So everything is also, you have the corresponding firmware in your BIOS in your computer. So it will immediately stop that process. It will, or if some process you cannot really stop it, but some process you can skip in between if you do not want. So this kind of software interrupts also important. CPU must process those software based interrupts. Okay, so these are this is the block diagram. So you have the interrupt and you have the edge detector circuit. So based on this, really about the clock signal. So you have the clock signal always. This is the making the synchronization. So you want to detect this interrupt either in the rising edge or the falling edge or either of these. So you can decide. And here you have the software interrupt register. Whenever you have the software interrupts, it will be stored temporarily here, and then the CPU will come and take it. And similarly, you can set up some don't care condition for interrupts, and you can have multiple interrupts, and the NVIC will set this priority to these interrupts. Okay, so and of course we have also events. So whenever we have events, also we are generating some kind of interrupts. Then the CPU will process that, and you can see that in the user interface. So external interrupts, it can occur rising edge or falling edge or both edges of the clock. So here is the clock. So each clock pulse is here. This is the off time. This is on time. So this is one duty cycle, off time to on time. So you want to execute the interrupt either in the rising edge or the falling edge or both edges. So you can set up this in your user interface when you set up the pin in the interrupt mode. So interrupt is occurred. Yeah, interrupt is occurred in, you can decide that. So rising edge means a transition from logic 0 to logic 1. This is logic 0, right? Logic 0, low level. And then this is the maximum plus 5 volt. So we are there is a transition from logic low to logic high. Transition from 0 to 1, that is called a rising edge. This is not a 1. I said this is the duty cycle. Okay, and then similarly falling edge means, so we consider to process the interrupt whenever there is a transition happening in the clock signals from logic 1 to logic low, logic 1 to 0, or both edges. You can also set up both edges. It means, so interrupt signals can be taken by the CPU whenever the transition happens in the clock signals from 0 to 1 or 1 to 0. Okay, for example, if you configure interrupt in rising edge mode, whenever the transition occurs from 0 to 1, then the interrupt occurs. The opposite operation occurs for falling edge mode configuration. So if you set up falling edge mode, then whenever the transition occurs from 1 to 0, falling edge 1 to 0, then the CPU will consider this interrupt. Dual edge mode configuration means you can either 1 to 0, either 1 to 0 or 0 to 1. So the interrupt can occur. Because remember, the clock signals are very, very important in the microprocessor and microcontrollers, because we are synchronizing the operations between different blocks. Okay, so you can see here. So first you check the system clock and then the RCC. This is the standard one. And then you are checking, setting up this pin. It's the pin number 6 into the red LED. And this is the output. and then you are setting up another pin as a switch, and then you are setting up another pin PC15. So that is going to be in this GPIO EXTI, that is the external interrupt or extended interrupt. So first, using this graphical tool, you can set up these things, and then later you go inside and then you can change the push pull mode or pull down mode and so on. So here, go to the clock configuration tab, and then you are changing the clock to the maximum, or you can change the prescaler value later. We will see that. So now you are in this configuration view. So here you can see different possibilities to change. So now we are after this the pins what we had set up just before, pin number 6, pin number 7, and pin number 15. So what we are doing now, this pin number 6. So here the output level, that is the LED, red LED. So here we can select the mode and change. And this is the interrupt. We set up the pin number 15, port C as the external interrupt. So here you can see here. So here you can see, you can set up either the interrupt can occur in the rising edge or falling edge, or both rising edge and falling edge. So you can set up the trigger here. And of course, you can set up this pull down mode or pull up mode. And here you can set up this everything is okay, you are enabled. So what happened here now, you are checking this is enabled or not. So you are enabling this by clicking this one. So now you can generate the C code, and then you will see the C code, and you can download the C code into your microcontroller, and you can check all these code. C code is already I uploaded as a sample code in Canvas. So you can also download this, but you can generate this code by yourself. That is the best, and you can compare with the sample code. Okay, so this is all about this interrupt.